Facebook, as you know, runs one of the largest data centers in the world. And Facebook decided not too long ago that they were going to open source the secret sauce behind their data centers and work collectively to make data centers more efficient and to meet their big scale-out computing challenges and similar challenges by other organizations. So we have Amir Michael, who's leading that effort at Facebook, to tell you all about the Open Compute Project's progress. Come on out, Amir.
Hi, thanks for having me. My name is Amir. I'm a co-founder of the Open Compute Project. I also lead a hardware engineering team at Facebook. So you might ask yourself, what's a hardware guy doing at a conference that's mainly about open source software? Well, let me tell you. All right, if we look at what we're here to discuss today, the open cloud, a lot of these logos that you see up here represent major projects that actually enable us to have an open cloud, that enable large enterprises, large companies like Facebook to deploy massive amounts of servers, massive amounts of infrastructure using open source technologies. Now, you should all be very proud of the point at which we are today, that we can do this with just open source technologies. However, this wasn't always the case. If we back up a little bit to 2001, a major leader at one of the large enterprise companies looked at Linux and decided that it wasn't quite ready for prime time. And that was really the reality. Regardless of the technical aspects of Linux at the time, people weren't convinced that it was ready for prime time, that it was ready for all the use cases in the enterprise. There was lots of challengers from Solaris, from Microsoft, different companies touting closed solutions that a lot of companies actually ended up using, right? If you were a decision maker at the time, you most likely weren't going to get fired if you chose to run your servers on Windows Server, for example. That was a safe bet. Linux at the time was a little bit more risky. Now, fast forward a couple more years, and in 2007, an analyst from Goldman Sachs actually made this statement. So this is a company that makes large financial bets on different types of technologies, and they actually found favor in Linux at the time. Now, how did we actually get there? What happened? The community was focused. There were definitely problems with Linux in the early 2000s. The community focused on solving those problems, on understanding exactly what those problems were and coming up with solutions for them. Now, the nice part was this was done in an open way. It was done in a way where people could go ahead, solve these problems, and then share them with the rest of the community. What that meant was that we weren't reinventing the wheel every time we found a new bug, or every time a new protocol was introduced. The problem was solved once. The community was highly focused on solving that problem, and then shared that solution with everyone else. Linux offered something very unique, and that was no lock-in. Linux was open source. You weren't tied to a particular vendor. By going with this solution, you weren't tied to their tech support. You had a large community of support helping you out. So people felt comfortable with going this route because it meant that they could easily change if they wanted to later. And ultimately, it offered a better value for customers. You can't really beat the price. Not only that, people understood that they could easily take advantage of all the different, hundreds of different developers that were working out there and contributing code back that they could then go ahead and integrate into their environments. And all this came for free. So the community in Linux has come quite a long way. As a matter of fact, as I go around and I speak to a lot of different companies that are starting to build out large cloud environments, every single one of them is basing their environment on an open source technology. Except for one, and I'll let you guess who that one is. Now, let's look at another story, something that's a little bit closer to my heart, to the hardware industry. If we go back to the early 90s, PCs were starting to become more and more popular, and so were peripherals. Lots of companies were building different types of devices that would go ahead and connect to these PCs. Small little webcams, scanners, printers, different types of mice, keyboards, joysticks. All of these companies were starting to develop new, interesting hardware so that you could plug into your PC. But they all had a problem. There was no good way of interfacing the PC at the time. There were a couple unique proprietary ports, like the serial port, which came in the DB9, came also in a PS2 form factor, or maybe the parallel port. And you can run that in a couple different modes, ECP, ECP, or EPP, ECP plus EPP. And all that was done because everyone who developed this hardware was focusing on a very unique application for it. But when people tried to use it for something else, it wasn't very easy. And the only thing that we ended up with was a tech support nightmare. Companies were more focused on developing and making their hardware run in some unnatural way rather than actually focusing on the peripheral that they were developing. And a lot of effort was wasted. Now, fast forward a little bit to 1994, 7 companies decided that enough was enough, and they were going to get together and come up with a standard, an easy way for everyone to interface hardware to PCs at the time. And then in 1996, they published a specification, and they created a nonprofit foundation called the USB Implementers Forum. And for a very small fee, a hardware company could go, get its own unique USB ID, and then start developing hardware based around the USB standard. That standard was open. Anyone could go ahead and download it. Anyone could write any type of software driver for it. It was easy to understand, and all the information around it was readily available. Most importantly, it was also expandable. It was very flexible. It was easy. To rely on all the work that the forum had done, that the initial 7 companies had developed, and just focus on developing your device. So this is a great example. These are 2 great examples of where openness wins. Right? None of this would have happened. We wouldn't have had these standards had these companies not been open around their innovation. Now, it's just a matter of time before openness goes ahead and, like in Linux, like with USB, becomes the de facto standard and becomes the best solution, the solution that everyone's going to choose. However, we're not all there yet in the cloud environment. You can't go ahead and deploy a cloud today on completely open source technologies. There's still one holdout, one place that isn't open just yet. The hardware industry today, which is where most of the money goes into when you build out a large cloud environment, is completely closed. It's filled with NDAs. It's filled with a lot of proprietary secret sauce, lots of things that companies and vendors believe add value to the hardware. However, the reality is, when you're building out a large cloud environment, the things that you really care about, like the CPUs, the DRAM, and the hard drives, those are the parts that really make sense for you. But all the extra secret sauce that people are adding on top of it make it much harder to adopt those things into your environment. When I first started Facebook, we had servers from Rackable, from HP, from Dell, from IBM. Every time we brought in a new type of server, we had to adapt our scripts, adapt our provisioning infrastructure, that we could accept a new piece of hardware. And why? Well, because everyone had a slightly different way of interfacing the hardware. We didn't actually care about that interface. We just wanted to get the basic data from it, but everyone made it a little bit more challenging and thought that they were adding value there. The reality was that they weren't. Now, I understand why the industry is closed today. Development of hardware costs a lot of money. There's lots of NRE and engineering fees that go into building out a server system. There's a lot of physical material that's involved in developing hardware. It's not like software, which code can be portable. There's no material infrastructure or physical device behind the code. Hardware, on the other hand, requires expensive things like manufacturing lines, like production, lots of expensive pieces of silicon that go into the hardware. So people tend to keep that tight, to keep that proprietary, because they're investing a lot of money in it. Now, it doesn't necessarily have to be that way. Facebook looked at the infrastructure we had, realized it was closed, we got tired of it, and we also wanted to build things a little bit differently. We were deploying at scale. We were deploying thousands of servers into our data centers, and we realized that the hardware industry didn't quite understand what that meant. They didn't understand what about the server was really important to us, the features that we really cared about, like power efficiency, like cooling efficiency. they were still building servers and hardware for the enterprise industry, for customers that would buy maybe 10 or 20 servers at the time, not thousands at a time. So we decided to go ahead and build our own hardware. And we built it because we were building for scale. We designed our own power supply, and we really focused on efficiency. The efficiency is over 95% efficient, more efficient than any other power supply in the industry at the time. We looked at server chassis and motherboards, and we decided that we could do them a little bit better. We have technicians that spend thousands and thousands of hours every year repairing servers in our data centers, and we need to make it easy for them. We took off all the paint, all the plastic bezels, all the lids and the screws that make it difficult to work on servers, and we came up with a vanity-free design, which looks kind of ugly, but is very, very functional and is very, very cheap. We did the same thing on the motherboard. We took off all of the out-of-band controllers, all of the proprietary pieces of hardware that came along with our motherboards from the standard vendors. And we found two interesting things. One is that the motherboard consumed less power, and two was that it was a lot cheaper. We went even a step further, and we designed our own rack as well. We made racks that were easy to deploy. We could deploy thousands of servers in a day in our data center because our racks were very easy to move around. The racks also required the technicians only to access the front part of the rack to fix any part of the server. Pretty simple concept, but it saved thousands of man-hours in repair time on servers when we did that. And then after we did all this, we realized very significant gains in both energy efficiency and in cost of our facilities. We did something completely different, which I think is even more revolutionary than the server design itself. We took all of our CAD files, all of our design guides, all of our specifications, and we published them. We made them open. We open sourced everything so that other people in the industry could go ahead and learn from what we did. So that the next enterprise, who's also going to be building a large-scale cloud, doesn't have to go through the same learnings like we did. They could go ahead and benefit from all of our work and go ahead and add on top of that as well. By doing that, we're going to see a much faster pace of innovation. We probably solved a lot of the same problems that our predecessors had. People like Google and Yahoo ran into these issues too. We probably had the same issues, but we are sharing with everyone not only the principles behind it, but also the secret sauce of how we actually solve those problems. And hopefully people will look at what we did, see that maybe there's some ways for improving it, and then add on top of that. And we also did this with the notion of doing this at scale. A lot of the world is moving to the cloud. There's no argument around that. There's going to be a lot more clouds coming out there. And we wanted people and vendors to see how we deploy at scale, to see what those challenges are. Not just for someone who's going to be building 20 servers or a small rack in a co-location somewhere, but someone who's going to be building massive facilities. And most importantly, we also did this to reduce environmental impact. As these clouds are developed, they're consuming huge amounts of energy. It's a big stress on our power grids, on the environment. We want to make sure that we use all of those resources as efficiently as possible. So we took all of this. We started the Open Compute project a little bit less than a year and a half ago, and we're already gaining quite a bit of momentum behind it. These are all companies who come and participate with us, who have joined the Open Compute project, who have contributed designs to the Open Compute projects, who agree with us that openness ultimately is going to be the winner when it comes to hardware. Efforts that are open are going to become the de facto standard. I believe in it. It's only a matter of time of when that's going to happen. Had Linux not come around, had USB not come around, then that universal standard which they both created perhaps could have taken a lot longer time to become adopted by the rest of the industry. If we don't join in and partake in the Open Compute project today, we're just delaying the inevitable. So I thank you for your time today. I encourage you to take a look at the Open Compute project and find a way to get involved. Thanks again.